Welcome to Path4Math. I'm Dr. Kristi Dorman, and today we're working question 2 from the 2017 AP Calculus AB exam. This question happened to be on both the AB and the BC exam, so if you're looking for help with the BC exam, you are in the right place as well. 2 of the 6 are usually repeated. 2 of the 6 free response questions, sometimes 3 of the 6 of the free response questions are repeated on the AB and the BC exam. This one was on both. So let's look at question 2. Parts A, B, C, and D are in this video. If you need other problems worked out, please look in my YouTube channel, and you can see a lot of other AP Calculus solutions to previous problems. So this question says, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customer removes the bananas from the display table, right, modeled by, and so they give you a function that's pretty complicated, from 0 to 12, and that's in hours. The reason I know that's in hours is in the next part it says where f of t is measured in pounds per hour, and t is the number of hours after the store opened. So right there, just reading that problem, I see that f of t is measured in pounds per hour. So that tells me, when I see that unit right there, if I'm going to be looking for total pounds, I'm going to have to take an integral of f of t because it's in pounds per hour. And when you integrate, you lose the per, one of the per units. So pounds per hour integrated would take you back to pounds. If you were to take the derivative of pounds per hour, you would end up with pounds per hour squared. So deriving changes the denominator of the units, and integrating takes one level off of the denominator. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by some function g of t, and that starts at 3 to 12 hours. Again, g of t is measured in the same units, pounds per hour. So the same logic applies for g of t. If you integrate, you're going to end up with pounds. And if you take the derivative, you would get pounds per hour, or pounds per hour squared. So question A asks, how many pounds of bananas are removed from the table during the first 2 hours the store is open? So it says pounds. When I see that unit, and it just says pounds, I know I'm going to be taking the integral of something. And in this case, I'm taking the integral of the rate of removal. And so all I'm going to do is have the integral over the time interval that these bananas were removed, which started at 0 hours and went up to 2. And I'm not even going to rescribe the function f of t. For my grader, I'm just going to write f of t dt. And then I'm going to type this in my calculator. Question 1 and 2 are calculator active. So rest assured, you will be having to integrate on the calculator and take the derivative on the calculator to be successful and earn all 9 points per question. When I type this in, if I'm using a TI-84, the keystrokes are math and then option 9. And you'll get an integral function, and you'll just type these in. You can use an X where I have a T right there on your calculator. Just be consistent with the variable. Plug in that whole entire equation and hit enter. And that's going to give you the value of 20.051. And 20.051 is pounds. So that is one of the 2 points available on part A. Then you need to interpret this in the context of this problem. And so during the first 2 hours, $20.051 pounds were removed. Done. Math 9, TI-84 gives it to you. Question B, part B. Find f prime of 7. And then it says, using correct units, explain the meaning of f prime of 7 in the context of the problem. I'm not going to take the derivative by hand. I could. It would require just a chain and a product rule for that second part. But I know that I can use math 8 on the TI-84 to take that derivative. So I'm going to type this in, and I'm going to evaluate this at x equals 7. And when I do, I'm going to put in my solution negative 8.120. And the units here, it was in pounds per hour. So when I took the derivative, that made it in pounds per hour per hour. So I'm just going to write hours squared. Then it asks you, what is the meaning of that? So what that means is when the store has been open for 7 hours, the rate at which the bananas are removed, and I know that it's removed, well, that's because I'm using the function f. So I know it's a rate at which bananas are removed is decreasing by negative 8.120 pounds per hour squared. That's it. Now, you wouldn't say decreasing and negative, so I need to switch that negative sign right there. Decreasing is what is interpreted by that negative sign that's in front of the 8. Full points awarded for that solution, and now you've earned 4 of the 9. Let's look at question part C. Part C reads, is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Give a reason for your answer. So at times t equals 5, what's actually happening at 5? Well, how many bananas are being taken away and how many are being added? If that's a positive number, then they're being added faster than they're being taken away. If that's a negative number, then that they're being taken away faster. You can look at this as a lot of lenses and you could still get full credit for it. You do need to consider what G of 5 is. That's how fast the display bananas are being added. So how fast are they going in? And then what about F of 5? That's how fast they're going away. So which one of these is greater would tell you if the pounds of bananas is getting higher or lower, or you could subtract these. And if it's negative, which by the way it is, it actually equals negative 2.263, and that's less than 0. So that means the pounds of bananas are decreasing on the display at t equals 5. You can look at this lots of ways. If G of 5 is greater than F of 5, if G of 5 is less than F of 5, or whatever you're looking at, just make sure you put it in the context of what you're looking at here. But since it's less than 0, it's decreasing at 5 hours at that instant. Question D. You know, it's interesting. We haven't used that 50 pounds of bananas, which was given at the beginning of the problem. And sometimes the questions will do that. They'll give you extraneous information. But on part D, how many pounds of bananas are on display at time t equals 8? No problem. At time t equals 8, we are going to have, well, let's think about it. We've got bananas being added from 3 to 8, and that's going to be the integral of g of t dt. That's going to give us pounds of bananas added. Now we need to take away the pounds of bananas between 0 and 8 that were removed. So that's going to be total pounds. This is pounds added, and this is pounds removed. All good, except we started with 50. So you've got to add that 50. Anywhere in that line will work. So you got your pound added minus the pounds removed plus how much you started with. And if you type all of that into Math 9 and add the 50, you will get 23 0.347 pounds. In the context of the problem, you would have at time t equals 8. There are 23.347 pounds of bananas. On display. And if you answer parts A through D in the following format or in the shown format, you will earn all 9 points available for this question. Thanks. See you next video.